Welcome to lecture series of Introduction to RF Basics. In this lecture, we'll discuss about the low noise amplifier. Low noise amplifier. A low noise amplifier is an electronic amplifier that amplifies a very low power signal without significantly degrading its signal to noise ratio. An amplifier increases the power of both the signal and the noise presented. If the transmitter is sending the signal will get attenuated, that is the signal power will be reduced due to the outside environment, and when it reaches the receiver, the signal amplitude power level will be in the reduced thing. So we need an amplifier to amplify the signal, because our signal will have a low power and it's very difficult to recover the data in it. And I'll explain the basic LNA next block. This is the low noise amplifier block, and here you can see this. We receive the signal from the antenna. That is, we have the amplitude as well as the noise in it. So this LNA will amplify both the signal as well as the noise. So signal to noise ratio is nothing but SNR input is nothing but signal power over the noise power, and here always this SNR output is gain cross signal power to the over the gain cross noise power. Here you can see why we get this gain is we are going to amplify both the signal power as well as the noise power. So this SNR out is equal to the SNR input. The output is equal to the S signal to noise ratio input. Whereas in ideal case, this is a perfect LNA. While designing this, SNR output is equal to the SNR input. Whereas in real world applications, will not get the SNR output will not be the equal to the SNR input. Why? Because this LNA will also have the internal components which generates the noise in it. So always will not have the SNR out will not be equal to the SNR input. Now here you can see this. Already we have discussed in the previous slide that what is the purpose of LNA, and here for example if we see this, we will get the noises not only from the signal and the outside environment, and there is we get the noises from the active components present in this LNA. So already we know this SNR out will not be equal to the SNR in perfect condition. So here in SNR out condition, here you can see this, there is some gain cross power to over the gain cross noise power into the amplifier. This amplifier noise is occurred due to this components present in this. So what happens is this noise, component noise of a present inside this LNA will get combined with the signals and this noises to the outside world. So what happens is this SNR out will get reduced. This SNR out ratio will, when it is getting reduced, we cannot able to amplify our inputs. That is, we will not get the whatever the power output is expected. So here our main purpose is to reduce the noises. So this we can able to separate the noise from the signal. So LNA purpose is to reduce the noise from the signal, and that is by using the amplifier. We are amplifying the signal. That is, we are increasing the power of the amplifier. Then after this, we have the minimum amount of noise in this. And now here you can see this LNA board of 722 FAME, and here you can see this an input signal, which it will be amplified and will get the output. And here this amplification process will have the VDD and ground process. And this is a block diagram of this product. You can see this board. RF is an input and we'll get the RF output. And here this block we called as an LNA block, and which is connected with the VDD and this ground. And here this signal, you can see this is an enabling signal which is used for RF pin is also used for enabling of the signal. And now, what are the requirements for LNA? So the LNA is, we need a low noise that is coming from the devices, that SNR out should be the high, that is, and that noise should get reduced. The main purpose of LNA is to reduce the noise and increase the SNR out ratio. And here the system should be of linear P, and we can use the low power consumption. So when we go for this battery consumption, battery usage, Then we have to think about of this low power consumption, low area consumption, and this gain. Of course, this LNA, this gain should be the important parameters, because in case of receiver system, if we are transmitting of this 20 minus 20 dB, which we are getting at this, but so here we need minimum of gain of 20 dB to get the 0 dB output. This is 0 dB. So if you have to be 0 dB of the signal, so minimum of 20 dB of this gain should be there to get the output of this gain. So the gain plays a major role when designing this LNE, and then the matching of this antenna and knob network. So the matching of parameters also, of course, plays a major role in case of this receiver system. So this gain and matching is an important parameter for the LNE case. In next lecture series, we will discuss about the mixers and oscillators. Thanks for watching.